integration by parts. Integration by parts. Because we have several expressions in mathematics, we have to look into how to handle the integration of each type of expression or function. Now, let's look at a situation like this. We have something like this, v dv. You know, we can easily say is equal to v squared over 2 plus c. Let's say v is a function of t or function of theta or anything like that. Let's look at this example. If we have sin theta, cos theta, d theta, you can see that v is equal to sin theta. If we differentiate this now, we are going to have dv will be equal to cos theta d theta. You know? So, with this, we can easily handle this one to say v dv. And that's going to be v squared. So, it's going to be, that's going to be v squared over 2 plus c. And that will give us sin squared theta over 2 plus c. You can see that's very easy to handle. That's very easy to handle. But assuming I have something like x squared sin x, you can see that sin x is not derivative of x squared. X squared is not derivative of sin x. So that is why we invented integration by parts. And you will see it helps in making the integration easy if we can just stick by the rules. Now, let's look at this. If we differentiate v uv, if we differentiate it uv, you know, once we differentiate, you are going to have u dv dx plus v du dx. Now, let's do something like this. U dx is going to be u dv dx plus v du dx dx. So at the end of the day, we are going to have uv will give us v du plus, oh, it's going to be u dv plus v du. Now, because of the way our integration is now, u and v, they don't have any relationship. So we are going to have something like this. U dv will be equal to uv minus v du. So when we have this, we have this. You can see that this one does not involve any integration. So our work now is, you see, this is u, this is v. Is to know what to pick out as u and what to pick out as dv. So what I just try to break down here is this. Follow these rules. When you have an expression you have to integrate and they don't have any relationship, the first thing is to take one as u, take one as u, and the other as dv. That's the first step. The second step is this. Integrate dv to give v. You can see. Thirdly, differentiate u to get du. So you can see, from this place now, we are going to get these two expressions. So you will now be able to say, okay, since you have u before, you will take this u, take u in one, and multiply it with v in 2. So it will give us uv. It will give us uv. Now, multiply with du in 3 and integrate. That is number 4. Now, okay, this is 4. This is 5, please. Subtract 5 from 4. If you can do this, you have already aced it. The only thing is to know which one to pick as u and which one as the v in every expression. I will give you the rules now. So 1, the rules now. If there is expression as ln x and any other, pick ln x as u. So, if there is x power of x but no ln, pick the power of x as u. Now you can see. So this one will take precedence over this if they are the same expression to be integrated. Now 3. If there is no ln power of x but we have exponential, that is e raised to power x or function of x. We have e raised to power function of x. Pick exponential as u. So if there is no ln x, no power of x, but we have exponential, that is e raised to power fx. Pick exponential as u. Exponential as u. Now we'll do certain examples now. Let's do x squared ln x. X squared ln x. You can see from our rules, the next, we have to take the next as our u now. So in this instance, ln x is u and x squared dx is dv. You can see. So that is the first step. Then we have to differentiate this and we have to integrate this. So du is equal to 1 over x. And v is equal to x cubed over 3. Now, but you know that this one is equal to uv minus t du. So the next thing is to get uv. What is our uv? This is our u and this is our v. So uv will be equal to x cubed over 3 ln x. And what will be our v du? V du will be equal to x cubed over 3 times 1 over x, which is equal to x squared over 3. So you can see. Now, let us now slot in this into this expression now. over 3, then x minus, what is v du? X squared, sorry, this one will be, yes, x squared over 3, yes. So which is going to give us x cubed over 3 then x minus x cubed over 3 plus c. Okay, this is over 3 times 3. Which is going to give us x cubed over 3 then x minus x cubed over 9 plus c. So we can still factorize if you want. So if I want to factorize for that, I can still say is equal to x cubed over 3 into in x minus 1 over 3 plus c. Now let's write expression here. X cubed e raised to power 2x dx. So what is in this situation? Our u will be x cubed because I told you the way it will be. The next, the power of x, then exponential. So x cubed u is equal to x cubed. dv is equal to e raised to power 2x dx. You can see. Now, what is our du? Du is equal to 3x squared. What is our v? Our v will be equal to e raised to power 2x over 2. Now, remember the expression that u dv will be equal to uv minus v du. You can see. So, uv, so therefore, we can now say that x cubed e raised to power 2x dx will be equal to uv, that is x cubed e raised to power 2x over 2 minus, what is our v? E raised to power 2x over 2. What is our du? 3x squared. 3x squared. Sorry, 3x squared dx. So that's what it should be. You can see, we are still back at something similar to this. We are still back at something similar to this. So which means that we have to reintegrate this part by part again. That is, we have to integrate this portion again by part. So let's leave this part. So let's work on this part again. E raised to power 2x, 3x squared. So we are going to have, so our u now will be, let me write like this, 3 over 2 into x squared e raised to power 2x. Yes. So let me quickly work on this. So what is our u in this instance? U equals x squared dv equals e raised to power 2x. Yes. So du will be equal to 2x dx. V is equal to e raised to power 2x over 2. So we can now easily do this to be, what's our uv? X squared e raised to power 2x over 2 minus vd e raised to power 2x over 2 times 2x dx. So you can see this again. So what does that give me again? So this one that is inside here, so that is the integration for it. So I'm going to have, it's going to give me x squared e raised to power 2x over 2 minus x e raised to power 2x dx. Which means that I have to do this one again. But because of the space, I want to summarize everything here. Now, I have brought everything up here now. So, this one is equal to x cubed e raised to power 2x over 2. 3 over 2 into brackets into all this. So, this is the only one giving me headache now. Let me work on this one. So, I have x e it has now reduced. So what is my UV? So U will equal to UV, that is x e raised to the power 2x over 2 minus V du e raised to the power 2x over 2 dx. So you can see everything has now become simplified. So it's going to be x e raised to the power 2x over 2 minus e raised to the power 2x over 4. So this one, I have to substitute for this one in this place. So I have substituted this into this expression. So I can easily work everything out now. So it's going to be x cubed e raised to the power 2x over 2 minus 3x squared e raised to the power 2x over 4 minus 3x e raised to the power 2x over 4. Oh, this one is the plus. Minus 3 over 8 e raised to the power 2x plus c. Now, I can still factorize further. So looking at it, you can see that e raised to the power 2x over 2 is common to everything here. But this one doesn't have x. So, to factorize effectively, all I just need to do is to bring this one out, and I'm going to have x cubed minus 3 over 2x squared plus 3 over 2x minus 3 over 4 plus c. So you can see, the situation is, when you see, after integrating, you might still come again to do integration by parts again.